Watch the complete playlist on the app Pions. Download the app now.
Let's start with our question number 1. Question number 1 says the radius of a circle is increasing at a rate of 0.7 centimeter per second. So if you look at the unit here is centimeter per second. So this is our dr by dt. So dr by dt according to the problem is nothing but 0.7 centimeter per second. That's our dr by dt. What is the rate of increase of its circumference? So we have to find the rate of increase of circumference when r equals to 4.9 centimeter. You have to be very careful. You don't have to put this initially. You have to put this value of given value of r, the radius, at the end. So what is our circumference of a circle? That is 2 pi r, correct? So if we differentiate, it will be dc by dt, and here it will be d by dt of 2 pi r, correct? Now when you are differentiating, 2 pi is a constant, it will be taken out, and here you left with dr by dt. And what's the value of dr by dt? So dr by dt is 0.7 into 0.7. So 2 into 0.7, which is 1.4 pi, correct? Centimeter per second. That will be your how the circumference is changing. Sir, what to do with this r, which is 4.9 centimeter? You don't have to do anything. You don't have to substitute because there is no place for r in the final answer. So our final result is 1.4 pi centimeter per second. You can leave the answer like that. Let's move to next one, question number 2. Question number 2 says the radius of an air bubble is increasing at the rate of half centimeter per second. So dr by dt, as you can see the units centimeter per second. So do we have to convert the centimeter into meter? No, this is not physics here, we are doing maths, so we can leave our answer in terms of centimeters, right? So if this final here radius is given in meters and that is given in centimeter, then you have to of course convert, but if both are in centimeter, that's fine. So the radius of the air bubble is increasing at the rate of half centimeter. So dr by dt is half centimeter per second. At what rate is the volume of the bubble increasing when the radius is this? So sir, if it is a perfectly spherical bubble, right, with a radius r, what will be the volume expression? So volume V will be 4 by 3 pi r cube, correct? Volume V is 4 by 3 pi r cube. Now what will be dV by dt? So dV by dt will be 4 by 3 pi, and differentiation of r cube. Differentiation of r cube is 3r square dr by dt. Let me repeat again. Derivative of r cube is 3r square dr by dt. 3 will come in front, r to the power 3 minus 1, which is 2. And since we are differentiating with respect to t, so hence it will be dr by dt. If there was r, if we were differentiating with respect to r, then it will be simply 3r square. Now let's substitute the value. So 4 by 3, this 3 and that 3 cancel. So you left with 4 pi r square dr by dt, correct? Now what is dr by dt as per the question? Half centimeter per second. And what is r? Now you have to substitute this value of r at the end. So don't substitute it initially in this place. If you will put initially r as 1 centimeter, this whole thing will convert into a constant. And derivative of a constant will always give you 0, which students get confused to. Again, I'm repeating, the value of given value of r is always substituted at the end. So 4 pi r square dr by dt, which is half. So it will be equals to 2 pi centimeter per second. That's our how the volume, centimeter cube per second. Be very careful with the units. Centimeter cube per second. That is the way volume is changing for the given air bubble. Let's move to question number 3. Question number 3 says a balloon which always remains spherical has a variable diameter. The diameter of the balloon, let me write here, diameter is 3 by 2 into 2x plus 3, correct? Variable diameter means it can vary, and it can vary with respect to whom? Sir, it can vary with respect to x. If you put x as 1, you will get a particular diameter. If you put x as 2, you will get a particular diameter, and so on. So as you change the values of x, the diameter changes. Clear? Find the rate of change of its volume with respect to x. We have to find the change of the volume with respect to x. But first, we have to express our volume in terms of x. And how do we do that? First, we will find the radii. So radius is nothing but diameter divided by 2. So if I divide this 3 by 2, 2x plus 3 divided by 2. Now you can convert this division, okay, into multiplication by simply converting this 2 as 1 by 2. So what is our radius for the given one? It will be 3 by 4, 2x plus 3. This is our radii of this spherical balloon. Now what will be our volume? So volume here will be 4 by 3, be very careful, pi r cube, correct? This is the volume of a sphere because this is a spherical balloon. Let's substitute the value of r. So this will be 4 by 3 pi. R is how much? 3 by 4 into 2x plus 3 whole cube. This you can write it here as 4 by 3 pi. 3 3s are 9, 3s are 27. 4 4s are 16, 4s are 64 into 2x plus 3 whole cube. Sir, can we expand this? Yeah, you can expand a plus b whole cube and differentiate. You will get the same answer. But I will use chain rule. So I'm not expanding it, okay? Because anyways, it will be in terms of x. We are not given with any value of x, right? So we can keep it in terms of x only. So 3 9s are, we can cancel this 3 9s are 27 and 4 16s are. So you're left with 9 pi by 16 2x plus 3 whole cube. This is our volume. What they are asking, the change in volume. So dv by dx. Be very careful, you are differentiating with respect to x as per the question. Find the rate of change of its volume with respect to x. So how the volume is changing with respect to x, that will be equals to d by dx of 9 pi by 16 into 2x plus 3 whole cube. So let's take 9 pi by 16 common out, and differentiation will be 3 will come in front, 2x plus 3 whole square, and derivative of 2x plus 3 into, let me remove this, into 2. Let me repeat again. So 9 pi by 16 is constant, it will come out of the derivative, and differentiation of 2x plus 3 whole cube. So first we will give preference to power, clear? 3 will come in front, 2x plus 3 whole square into 2. Okay, if you have any confusion in differentiation, go through the lectures of differentiation once again. So it will be 2 3s are 6, 6 9s are 54 pi by 16, which you can further cancel out with 2 and make it here 8 into 2x plus 3 whole square. Done. This is the way volume is changing with respect to x for this particular question. Let's move to question number 4. Question number 4 says water is dripping out from a conical funnel at the uniform rate of 3 cu. Sir, what is this cu? This is a short form of writing cubic. Be very careful. If you find somewhere cu like this is cubic centimeter per second, just to confuse you, right? And unit of cubic centimeter per second, it's a unit of what? dv by dt. So be very careful. Units will help you a lot in these type of questions. So dv by dt is 3 centimeter cube per second, or cubic centimeter per second. That is our volume. So water is coming out of a conical funnel. Okay, conical, let me just make a conic here, a cone. Okay, and the water is coming out of this funnel. Okay, at this dv by dt is given. Okay, fine. So basically the volume is changing with respect to this, okay, through a tiny hole at the vertex of the bottom. So from here the water is coming out, okay, from like this. Great. When the slant height of the water is 5 centimeter, which is okay, so let me first explain you what are the things here. This is called the radius r, this is called the height of this cone h, and this is called the slant height l. Let me repeat, there are three parts of a cone: r, h and l. L square is always equals to h square plus r square. That we know because of Pythagoras theorem, right? Because r and h are perpendicular, and at any instant L will be hypotenuse, correct? Now the semi-vertical angle, which is here, this angle theta, let's take the semi-vertical angle as theta, because at each and every place the theta remains constant. The angle is fixed for a cone, right? So we can take for what angle our this hypotenuse is L and the perpendicular here is R, right? So we can take sine of angle theta will be equals to perpendicular. What is the perpendicular? R upon L, correct? Now what is our R? R is how much? R of the radius at any instant. Radius is 4 and L is how much? That is 5. So sine theta is our uh, fixed, that is 4 by 5. If sine theta is 4 by 5, okay, we can find our L also. So L is already there. H we can find. So H will be how much? H square will be equals to L square minus R square. So L is how much? L is for that instant. But we can find, wait. Not using this equation, we'll find it using tan theta. So tan theta, sine theta is 4 by 5, right? So what will be the height at that instant? If sine theta is 4 by 5, perpendicular upon hypotenuse. So this is our perpendicular, this is our hypotenuse. What will be the base at that instant? So base will be hypotenuse square minus perpendicular square under root, correct? So what is our hypotenuse? 5. 5 square is 25 minus perpendicular square is how much? 16. So that is how much? 25 minus 16? 9. And root of 9 is 3. So here we got our base as 3. So perpendicular is how much? Perpendicular is our 4 and base is how much? 3, correct? So tan theta is 4 by 3. And what is tan theta? R by H is 4 by 3, correct? So now this is very crucial relation. R by H is how much? 4 by 3. If R by H is 4 by 3, we can substitute it in our this equation to find a relation between one of them, ln. Okay, so let me write R is equals to, let me write here, R is equals to 4 by 3 H, correct? So if R is equals to 4 by 3 H, then L square will be equals to R square. What is R square? 4H by 3. So 4H by 3 whole square plus H square. So this will give us 16 by 9 H square plus H square. And 9 plus 16, 25 by 9 H square L square. Now, if you differentiate both the sides, you will get 2L dl by dt will be equals to 25 to the 50 by 9 H dh by dt. Correct? This is very, very important equation. dl by dt that we can find, okay, using that. Later we will substitute it. So this is our equation 1. 2L dl by dt is equals to 15 by 9 H dh by dt. And now this we will make use in our remaining part. Clear? So let me solve it on the other page. Okay. Now what is the volume of a cone? Volume of a cone is 1 by 3 pi r square h. And r square is nothing but how much? L square minus h square. Correct? From our equation into h. Now here this will give us 1 by 3 pi L square h minus h cube. Okay. Now the derivative, let's differentiate it. So differentiation will be 1 by 3 pi derivative of L square 2L dl by dt, correct, into h as it is plus L square as it is dh by dt minus 3h square dh by dt. Okay, now we will substitute the values to get here. This is our dv by dt. Okay, this is simple differentiation. So L square, I have used here multiplication rule. So L square is 2L dl by dt into h minus, okay, plus, because they are two multiplied together. So L square as it is, derivative of h is dh by dt, and this will give you minus 3h square dh by dt. Correct? Now let's go back and find the value of dh by dt from here. So L value at that instant when it was 5 and 4, that time L value, now I'm taking equation 1 here from 1. L value is how much? Sir, L value here is slant height is 5. So 2 into 5 dl by dt is equals to 50 by 9 h. How much is h at that time? We calculated it over here on the right corner. It's 3 dh by dt. Correct? So let's cancel out this 3 threes and dh by dt. Let me take this 3 on the top there. So 10 into 3 divided by 50 dl by dt, that is equals to how much? dh by dt. And 10 and this cancels out, it will be 5. So this will give you 3 by 5 dl by dt. Okay, so this will give us 3 by 5 dl by dt, that is dh by dt. This we can substitute in our this expression. So 3h square 3 by 5 dl by dt minus L square into 3 by 5 dl by dt plus 2 into L into h dl by dt, and here we left with pi by 3 to dv by dt. Now let's substitute the values of L, h and dv by dt to get. So dv by dt here is 3. Let me write here dv by dt is 3 centimeter cube per second, 3 centimeter cube per second. And what is our L? L value is 5, h value is 3. So let's write here L value is 5 and h value is 3. Let's substitute to find dl by dt. So dv by dt is how much? 3 equals to pi by 3 2 into L 5 h 3 dl by dt. L square 5 square 3 by 5 dl by dt. 3h square 3 square 3 by 5 dl by dt. Let's simplify. Let's take this 3 on the other side. 9 by pi equals to, let me simplify now here only. 2 5s are 10, 3s are 30. 30 dl by dt. 5 and 1 of the 5 will cancel out, and you left with 5 3s are 15 dl by dt. 3 3s are 9, 3s are 27, 3s are 81. 81 by 5. Correct? So this will be dl by dt. I am taking common here. dl by dt taking common. What we left with here? 30 plus 15, 45 minus 81 upon 5. Correct? And this implies 9 by pi equals 5 5s are 25, 5 4s are 22, 25 minus 81 upon 5 dl by dt. Correct? And this implies dl by dt. Let's cross multiply. So 9 5s are 45 upon 15 minus 5 minus 1, 4. Correct? Now 12 minus 8, 4, 144. Correct? So 144, and this will be pi. So 45 upon 144 pi, this is the way the slant height is changing. Quite interesting problem. So initially I thought that the angle is not given, but actually first you have to convert it into angles and then simplify it. Yes, let's move to our next question. Our next question says a stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. So speed here is our speed, let me write it as s. Speed here is 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeters, so r is 8 centimeter, how fast is the enclosed area increasing? dA by dt you have to find. Correct? So the speed is nothing but how the radius of the circle is changing, right? Distance per unit time is speed. Like if the waves are coming out like this, okay, these waves are coming out with that speed, and the speed is the distance traveled per unit time. So dr, how the radius is changing, that will be the speed, right? So area of a circle is nothing but pi r square. Now if you differentiate it, dA by dt, that will be equals to d by dt of pi r square. Correct? Now if I take pi out, it will be d by dt of r square, and derivative of r square is 2r dr by dt. Now let's substitute the values of r and dr by dt. So what is our r? R is 8. and dr by dt is 5. So 5 2s are 10, 10 into 8, 80. So our dA by dt is 80 pi centimeter square per second. Let's move to our next question. Question next is saying that our here, okay. Question 6 says water is being pumped into a conical reservoir. Reservoir is same as conical flask or conical container of height 10 meter. So this is our conical flask of height 10 meter and radius 5 meter at a constant rate of 2 cubic meter per minute, because all of them are in meter, so that's why they have given this. Okay, cubic meter is what? dV by dt. Let me repeat again. Cu is cubic, so it is volume, 2 meter cube per minute. This is the way of writing cubic meter, correct? So 2 meter cube per minute, that is our dV by dt. How fast does the water level rise from the depth, from a depth of 2 meter? Clear? How fast does the water level rise from the depth of 2 meter? So if this is the level of 2 meter, 2 meter is what? Our height. So what you have to find? The slant height. How the slant height? dl by dt. Correct? So let's take this height as 2 meter at this instant. Okay. And this is our L. We have to find dl by dt. Okay. Now here you can see that there are three variables given. So this is quite easier than the previous question. So here what you have to do, very simple. What is our R by H? Okay, let's find R by H. That is equals to 5 by 10 straight away. So R by H is 5 by 10. So R is equals to half H. You can say like this. R is equals to half H. Clear it is? Great. So what will be our slant height? L square will be equals to R square plus H square. And R is half H. So that will be H by 2 whole square plus H square, L square. So this will be equals to 2 and this will be H square by 4 plus H square, correct? And 4 plus 1, 5 by 4 H square, that will be our L square. So L square is 5 by 4 H square. So what will be our derivative? Okay, here we can find dl by dt from this is not our first equation. Okay, so let me write here, differentiate it here, twice of L dl by dt, that will be equals to 5 by 4 2h dh by dt, correct? Now this 2 cancels with this 2. Okay, and dl by dt, let's take this h on the left hand side, so L upon h, and 5 by 4, it will be 4 by 5, that will be dh by dt. You have to be very, very careful here. Okay, 4 by 5 L by h dl by dt. Clear? Okay. Now if R and H, they are in the ratio half, you can see here R is equals to, now be very careful with this equation, I'll modify this equation within a minute. This is equation 1. So if R and H, they are in the ratio 1 is to 2, right? So when H is 2 meters, when the depth is 2 meters, what will be R at that instant? R will be equals to half into 2, correct? When height was 2 meter, height is depth here, right? So when the depth is 2 meter, what will be the radius at that time? 1 meter. Because it is obvious that if the height is or the depth is 10 meter, the radius is 5. So when the depth become 2, the radii will become 1. 2 by 2, which is 1 meter. And if at that instant, if R is 1 meter and H is 2 meter, what will be our L? Sir, L square will be equals to R square plus H square. So let's substitute the values. R is how much? 1 square, which is 1. H is 2 square. So 2 2s are 4 plus 1, 5. L square is 5. And this implies L equal to root 5. Correct? At that instant. But what they are asking, how does the water level is rising? Which means dl by dt they are saying. So L is root 5 and H is 2. Let's substitute these values in equation 1. So in equation from 1, 4 by 5 into L root 5 upon H 2 dl by dt is equals to dH by dt. This will be required later in the differentiation, correct? And this will become 2 root 5 upon 5 dl by dt, that is our dH by dt. We found how the height is changing with respect to time, correct? Done. Question is not done. We found a relation between H and L. Now this will be equation 2 and will be used for volume because volume is given. So let's write here. Volume here is 1 by 3 pi r square h, correct? And for a cylinder, r square in terms of slant height will be L square minus h square to h. Okay, now you can follow some other textbooks or online stuff where you can find that they have converted h and made it under root. Now students finds this root thing little complicated. That's why I converted r square. Okay, that's the only purpose. So 1 by 3 pi L square h minus h cube, correct? Now differentiation, let's differentiate it. So dv by dt 1 by 3 pi. Now derivative of L square will be, let's differentiate using multiplication, 2L dl by dt into h plus L square as it is dH by dt minus h cube 3h square dH by dt, correct? Done. So here let's substitute the previous value of our dH by dt, h and L. So let me just write on the top here first this thing. So 2 root 5 upon 5, 2 root 5 upon 5 and dl by dt, that is our dH by dt, correct? That's the value of dH by dt. What is dV by dt? 2 meter cube. So dV by dt is 2 meter cube per minute. And what is our L and H? Sir, L here is root 5 and H here is 2. L here is root 5 and H here is 2. Correct? Let's substitute the values. So this will become pi by 3, 2 times L. L is how much? Root 5 dl by dt as it is, and H is how much? 2. Plus L square, which is 5 dH by dt minus 3 times H square, which is 4 dH by dt. Correct? And what is dV by dt on the left hand side? dV by dt. Wait a minute, I did a mistake or what? No, I have kept dH by dt only. Correct, it is. Now, what is dV by dt? 2. Correct? Now, let's remove this, okay? Or let me just take here this 3 on the other side. 3 to the 6 by pi. This will be equals to 4 root 5 dl by dt. Correct? I took this 3 and pi on the left hand side and I opened the bracket dl by dt plus 5. What is dH by dt? Now look at the top right corner. dH by dt is 2 root 5 upon 5 dl by dt minus 12. What is dH by dt? 2 root 5 upon 5 dl by dt. Correct? Now let's take dl by dt common out. So we left with 6 by pi equals dl by dt here. And in the bracket we left with 4 root 5. 5 and 5 cancels. 2 root 5 and minus 24 root 5 upon 5. Correct? That can be further simplified as, let's do it here. 6 by pi equals dl by dt into, let's take here LCM 5, 20 root 5 plus 10 root 5 minus 24 root 5. Correct? Great. Now 20 plus 10, 30. 30 minus 24. 30 minus 24 is 6. So let me just remove this and write it here. 6 root 5 whole divided by 5. And when you cross multiply, dl by dt will give you as 5 goes on that side. 5, 6 cancels. Root 5 pi. Or like they write it, you can just remove this root 5 and make this as root 5. So root 5 upon pi. That's our how the slant height is changing. Done. Let's move ahead with our next problem. Very common question from your textbook. Okay. So question 7 says a ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. So let's draw a wall here and let's say this is a ladder. Okay. So let me increase here up till the ground. So let's say this is our ground. Clear? Okay. So this is a ladder 5 meter long. So this is something which is constant, which is not changing. The size of the ladder will never change, right? The bottom of the ladder is pulled along the ground. So if you are pulling it along the ground from this side, so this bottom will reach up to here. And because that is reaching up to here and the hypotenuse is fixed, which is the ladder size is fixed. So what will change? The perpendicular will change. Okay. So this will come down here because this is increasing, correct? So perpendicular, base and hypotenuse, the whole game is of that only, right? Okay. So let's read the second line once again. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second, which means the base is changing with respect to time. dv by dt is 2 centimeter per second, correct? How fast is its height on the wall decreasing? How fast is its height on the wall decreasing? Which means they are asking dp by dt, perpendicular, how it is decreasing when the foot of the ladder is 4 meter away. So here at this very instant, the base is 4 meter away. Correct. So if the base is 4 meter away at that instant, hypotenuse is 5, we can find the perpendicular at this instant, this length, right? Because that is 4 and that is 5. So this will be also fixed. So at that instant, base perpendicular will be 3. How? Using Pythagoras theorem, root under 5 square minus 4 square, which is root 9, and root 9 is 3, right? Clear. Okay, fine. So let's use our simple concept of trigonometry. H square equal to p square plus b square. Now, when you differentiate this Pythagoras theorem, this h square derivative with respect to time will be 0. Why? Because the size of the ladder is not changing. And here d by dt of p square plus d by dt of b square. Correct? Now this will be 0 on the left hand side and this will be 2p in dp by dt. Correct? And this will be 2b dB by dt. Now, if I take this 2b dB by dt on the left side, it will be minus 2b dB by dt. That is equals to 2p dP by dt. Now, if I take this 2p on the left hand side, first cancel 2 with 2. Let's take p on the left hand side. Minus b upon p dp by dB by dt will be equals to dP by dt. And we have to find dP by dt only. So what's the base at that time? The base at that time is 4. Perpendicular is 3. And what is dB by dt? That's 2 equals to dB by dt. Correct. So this implies our dP by dt, the rate of change of perpendicular with respect to time, is minus 8 by 3. Sir, what is minus? Minus represents the decreasing value because it is going down. Since it is decreasing, that's why it is getting a negative value. So let's see what question number 8 says. Question number 8 says, sand is pouring from a pipe at the rate of 12 cubic centimeter per second. So this is a pipe. Let's draw a rough pipe here. This is our pipe. And volume dV by dt, which is coming out from this pipe, is 12 centimeter cube per second. The falling sand forms a cone. So if the sand is falling down, it is forming a cone here. Okay, like this. It is forming a cone like this. Okay, fine. If it is forming a cone on the ground in such a way that the height of the cone h is always 1/6 of the radius of the base. H is equals to 1 by 6 of r. How fast is the height of the sand increasing? Now this is quite easier than the previous question because they are asking height. Straight away height is changing. Okay. So how fast is the height of the sand increasing? So dh by dt they are asking. When the height h was 4 centimeter. So here given data is h equal to 4, which we will make use later on. Clear? So first of all, what is the volume formula? Volume of a cone will be 1 by 3 pi r square h, right? Because the volume with which the sand is coming out of the pipe, that volume is forming the cone, right? So that volume of sand will be equal to the volume of the cone which is formed. So V is 1 by 3 pi r square h, right? Now let's differentiate it. It will be dV by dt. Okay. But before we differentiate, we have to convert this two variable equation into one variable equation first. So our h is 1/6 of r and we have to find h. So let's convert r into h. So r will be 6 times h. Correct? Be very careful. You have to find dh by dt. So you have to keep h in this equation. So let's put r as 6h. 1 by 3 pi 6h whole square into h. 1 by 3 pi 36h cube. Okay. And this implies, here I am solving, volume V equals to 12 3 is a 36, 12 pi h cube. Let's differentiate it with respect to time. So dV by dt will be equals to 12 pi is a constant, derivative of h cube 3h square dh by dt. Correct. Now you are already given with the h value, so we can substitute these values and find dh by dt. This was quite easy. So dV by dt is rate of change of volume. What's the rate of change of volume? 12. 12 pi 3 h 4 4 is a 16 dh by dt. Correct. 12 and 12 cancels. 16 3 is a 48. So 1 upon 48 pi. That is the way height is changing with respect to time for this conical sand. Clear it is? Let's move to next question. Our next question is question number 9. It says that the length x of a rectangle is decreasing at the rate of 2 centimeter per second. Quite interesting question. Most of the students go wrong here due to a silly mistake. And what's that silly mistake? Since it is decreasing, the length is decreasing, dl by dt. Okay, or since they said L as x, so dx by dt, they don't take this negative sign. That's the most common mistake students do. Though this comes in very simple 1 or 2 marks, but students do this mistake. So dx by dt is minus 2 centimeter per second, and the width is dy by dt is how much? 2 centimeter per second, because it's increasing. One is increasing, one is decreasing. You can clearly see from plus and minus. When x is 12 and when the length is 12 and the breadth is 5, find the rate of change of perimeter. So let me solve here perimeter. Perimeter is nothing but 2 times L plus B, right? This is our formula for a rectangle. And what is the length here? X, and breadth here? Y. This is B. So let's find the rate of change of dP by dt. Derivative of x dx by dt. Derivative of y dy by dt. Now here it will be 2 times. What is dx by dt? Minus 2. What is dy by dt? Plus 2. Correct? So minus 2 plus 2, it became 0. Clear it is? So how the parameter is changing? It's not changing with respect to time. It's fixed. Because the length is also increasing and the breadth is also increasing in a similar fashion. Great. Let's see if the area of the rectangle is changing. So area is nothing but length into breadth, and that will be here x into y. So dA by dt, that will be equals to differentiating dy by dt plus y dx by dt. X is nothing but 12 at that instant, dy by dt is 2, y is 5 at that instant, and dx by dt is minus 2. 12 2s are 24, minus 5 2s are 10. 14 centimeter square per second. This is the way area is changing for this given rectangle.
Watch the complete playlist on the app Pions. Download the app now.